Well, I was also one of the active TensorFlow learner back in 2015, and I was exploring that tool. And after some time, Google made a Python API open source and all those. And from there onwards, I've been working with many organizations as a data scientist. And then prior to Intel, I was working with one of the big three strategy consulting firm. And then I thought of owning a product which is for open source community. And then I joined Intel, and the product which we have built, and it is being used by a lot of users across the world. It is mainly for TensorFlow developers. So we had a tool called OpenVINO, and OpenVINO is an inference accelerator tool that accelerates speed of inferencing on Intel hardware. And that tool is a standalone API. But what we did, we brought that tool into TensorFlow ecosystem. Suppose you are building an application, and 99% of the time, if you're building on your computer, it will have Intel CPU. Uh, then in that case, if you want to accelerate its inferencing speed, you just need to add two lines of code to your existing TensorFlow code. I'll talk about this in more detail once I share my screen. But this product is called OpenVINO integration with TensorFlow. So we have a native product, and through this integration, we have enabled TensorFlow developers to quickly utilize the toolkit optimizations that OpenVINO has without coming out of their TensorFlow ecosystem. No need to learn any new API. So this is the whole context. Okay. So in the session, I'll just quickly introduce you to the tool. Then I'll point you to some resources where you can try along with me Jupyter Notebook. After that Jupyter Notebook, if you try with me, and then once you, it will be very easy when you can try it on your cell phone if you don't have access to a PC or something, right? And maybe I would strongly recommend just run the cells of the notebook and see how easy it is. Yeah, so let me share my screen. Let me know once you can see. Mm, 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 mm. Yeah, Vijay, can you confirm whether you can see my
Yes,
screen or not?
we can see your screen.
Yeah, perfect. So well, so let's start. So these are the points which I have just summarized what and all I'm going to cover. So well, we know about AI. AI is like everywhere. I would say now this decade, I would say it belongs to intelligent apps. Now we know how to develop apps, right? It's the differentiating factor of any product nowadays is AI. How efficiently they are utilizing AI. Well, there are many types of data, and through AI, we sense, comprehend, we act on scenarios. So there are things, and there are many AI technology. And being a TensorFlow user group, you must be knowing about computer vision, audio processing, NLP, knowledge representation, ML, and expert systems. So these are the basic technologies or the popular technologies, I would say, of AI. Now, this Venn diagram everyone would have seen, like AI is the big umbrella, and within that we have machine learning, and deep learning is a special kind of machine learning algorithms. Like we have other algorithms within machine learning, like linear algorithms, like linear regression, logistic regression, tree-based algorithms, like decision tree, random forest, Bayesian algorithms. Similarly, we have neural network-based algorithms, and neural network with some more depth are called deep learning algorithms. They are neural networks and deep learning. The way we are going to organize a neural network uh, that creates a lot of deep learning architecture. And the vanilla one you would be knowing is called ANN, artificial neural network, which has some input layer and one output layer, and all the nodes that you see in a neural network are intelligent units, and they are connected to each other, and the connection once you go through there is a weight associated with each connection, and once you go through the way we train a neural network, right, then you will come to know how these weights are derived out of the data. So basically it's a network, and we call it neural network because it resembles our brain, and it is a collection of intelligent units, and way we are going to organize these networks that gives birth to many neural network architectures. And the vanilla one is ANN that you can see in the picture. So I'll not go very deep, but I think I assume like everyone would have basic idea about that. Else I had already covered it. So basically, what we have to carry here is it's a type of algorithm. It is an intelligent unit. It does something useful with structured and unstructured data. So one of the useful things that neural network is capable of doing is computer vision activities or tasks. Computer vision, what it is a field of AI that enables computer and systems to derive meaningful information from what? From digital image, like our eye, like our vision, right? Human vision is also like that. We have eyes, and we look at objects, and then we comprehend. Our brain comprehends. Like eye is the way to get data, and once it reaches our brain, we comprehend. Okay, we recognize a friend from a distance. Okay, and also when we look at any picture, we can detect objects out of it. So there are many computer vision tasks. I'll just talk about two. One is image classification. I give you an object, the image, and you have to tell me like how you're going to classify that image. Suppose I built an image classifier that is capable of detecting uh, whatever image it will get, it will detect whether it has cat or not. So there are two classes. One is cat, another is no cat. So you give an image, then you get like whether that image belongs to a cat or not. So that is the output what is expected. And the second type of use case is object detection, where I train an object detection algorithm. It is capable of detecting certain objects in the image. So what it does, once it gets an image, it identifies what objects are present in that image. Along with that, it also provides you information where it is present in the image. So it tells you the label of the list of objects and where they are in the image. So in the picture, you can see like there is a matchbox and there is a bounding box surrounded by that. So in the output, I'll get a label name matchbox. Along with that, I'll get x1, x2, y1, y2, like xy coordinate of this the bounding box. Similarly for the watch. So these are the two very popular computer vision use cases. Any question till now? I'll take a pause. I want to make it more interactive, uh, or else I'll go ahead.
Yeah, if you have any question, feel free to unmute and ask your question.
Yeah, and Vijay, if something comes on chat, actively I'm not able to see the chat when
No
I'm
problem.
presenting. So
I will
please
let you
help
know.
me.
Sure.
Yeah. Okay, so let's move forward. Uh, we all know about TensorFlow. Uh, It is a TensorFlow group, right? It's an open source library. It has a lot of utility functions that helps you write neural networks, and it was developed by Google Brain in 2015, uh, and it was made available to the community. Most of its part were used by Google before that, right? But with the branding and all, they released it in 15. So there are many AI use cases. Now, if you think about some real-time use cases where your model is trained, you are satisfied with the accuracy of the model, okay? But you can't afford some lag. You want that model to be super fast, right? If I build an object detection algorithm that detects a person entering into my society compound, I cannot afford a delay or lag. I want that to be super fast. So that is where AI on the edge or edge AI is a very new field where the inference or the prediction happens on the device itself, on the edge device like a security camera, or and there you just have uh, means more inferencing speed, less lag, and real time prediction can happen. And there are many sectors where we need these kind of things, like visual inspection in manufacturing, where I have to detect all the people, any security violation is there or not, right? Or any like I can also even use it to detect whether a person is wearing PPE kit or mask, or maybe in some critical things like we can also check whether people are wearing helmet or not, right? Accordingly, we can trigger some security alarm. In healthcare also we have seen like in we can analyze a lot of MRI scans, and basis that we can have some analysis on the cancer or other diseases. Agriculture also I can have like suppose I have a lot of animals, then I can monitor their count. I can simply install a camera, and that camera is facing the area where uh, animals are grazing or moving around. Then I can constantly have a count on my animal. I can monitor that. Similarly, it can go for crop monitoring, maybe for any particular type of how many crops are there, or any other animal is coming into your farm and trying to destroy. So those kind of things we can actually figure out, and this is very popular in agriculture sector. Even in retail, we can monitor the store shelves, how many Pepsi can are kept over there. If anything gets stocked out beforehand, I can place an order, right? So those kind of inventory monitoring, there are those kind of use cases also present. So now let's talk about training and inference. So these are very two different stage. In training, what happens, like you have an untrained model. You decide on the architecture. Okay, I'll use this algorithm. You decide which algorithm to use, or maybe you'll decide over after training it and testing its accuracy. You lock the decision. But initially, you have an untrained model. Then you get a training data set. Then you make use of some AI framework, maybe DL framework like TensorFlow. Now, using that TensorFlow, you write some functions where you pass on data set, and that deep learning framework has some already implementation of some optimizations, Adam, and all those. And your model gets trained eventually. You call some functions, you provide data, you decide on the architecture to use, and accordingly, you will get the model will be trained after that. Okay, this is the training phase, and once the model is trained, you are satisfied with the accuracy, you have done all the fine tuning and all those. Now you want to make use of the model in the real world. You get a new data, you the trained model processes it and does prediction or inferencing, maybe classifying objects, or classifying images or detecting objects in images. So these are the two different phases. And our solution, the solution I'm going to talk about today, will mainly deal with inference. It accelerates the inferencing speed. Yeah. So in mainly the challenges in deep learning is unique inference need. Based on your use case, you have your inference need, right? Uh, Also integration challenges. There are many uh, integration challenges. There is no streamlined way of end-to-end development workflow. That means from training to final deployment on a hardware, because finally you are going to make use of it in the real time, right? And there's no one solution, and there are different requirements. Sometimes you just require to have a CPU or a small device. Sometimes you need more device, right? Based on your use case, there are different hardwares available where actually your model will run. Yeah. So then there comes our OpenVINO toolkit. So this is a big toolkit. It's a separate API that caters all AI frameworks: MXNet, Cafe, Keras, TensorFlow, Onyx Runtime, PyTorch. Do you have your model trained in any of these frameworks? The model is trained. It's all you are fine with the accuracy and all. Now you want to deploy it somewhere, right? You want to uh, make use of the trained model. So using this API, there are certain steps we do, and then your model will be able to run on Intel hardware uh, efficiently, more efficiently. Out of the box, it runs on Intel hardware. But if you want more acceleration, then in that case, OpenVINO toolkit brings lot of optimizations, that graph level optimization. It does quantization. There are graph fusion techniques. So there are many optimization which takes place because of this API. It's a big API. uh, then why do we need this? Because we want high performing deep learning inference. We want streamlined use development and ease of use. You have a model, you just make use of OpenVINO toolkit, and that's all. Then you can test it out with different hardware, uh, uh, just for the final case. And once you do it, you can deploy anywhere on any hardware device. So typically, I'm just giving you overview. This is very powerful tool, but this is not the main agenda of this call. The main agenda of this call is how we have taken this OpenVINO and integrated it for TensorFlow developers so that they don't have any tension. Okay. But as a developer, they just need to add 2 lines of code. But before that, I just want to give you overview that how the typical workflow in OpenVINO works. Do you have a model in TensorFlow? Then in OpenVINO toolkit, you have a module called Model Optimizer. It's a Python-based tool that converts the TensorFlow model, the saved format or .pv format, right, into an intermediate representation. So your TensorFlow model gets converted into an intermediate representation. The model and that intermediate representation is nothing but 2 files will be created out of your model, that is .bin and .xml. .xml file will hold the topology of your model, and .bin file will contain the weights and biases of the model. Okay, it can be even quantized into int8 with post training optimization toolkit available in this OpenVINO. So then this is the first step when your model from TensorFlow format gets converted into intermediate representation. Lot of optimizations happen, and your model becomes lightweight. Okay, without losing accuracy. And it becomes into a format which is framework independent. .bin and .xml file any code can consume, right? Then we have an enhanced inference engine where these intermediate representation runs, and that inference engine has plugins for all sort of hardware, is super optimized for that. So this is a second layer. So there are different steps in like utilizing TensorFlow application. You have to learn this API, and then convert the model into intermediate representation, and then run it on it's another module called inference engine, and that's it. So yeah. So, but what we thought, like, okay, a TensorFlow developer is there, okay, he or she knows TensorFlow well. They have their workspace set in a way that they have all setup of environment setup for TensorFlow. Now, they don't they should not do offline model conversion in the first place. They should first utilize OpenVINO toolkit optimization, then they can think of model conversion. Then there are many TensorFlow developers who don't want to learn any new API. And for them also, we wanted to have some low code solution approach. And another thing what we saw is there are many models which can't be converted into intermediate representation as is, because there are many operators involved, and daily new architectures comes into market daily. Many new operators can get introduced. To those For those, we have to write custom functions. So just to deal with these things, we came up with OpenVINO integration with TensorFlow, where we have integrated OpenVINO inside TensorFlow. What I mean by how we have integrated, we'll see here. So in the right hand side, you'll see that typical TensorFlow application where you are loading the model in line 20. You are just inputs. You are just playing with the input side, making it fit for the model. And when the input size is set, then you pass it to the model, and you get the prediction. And there I have added these two lines of code. I've imported OpenVINO integration with TensorFlow, and then I've set the backend. Suppose GPU, CPU, MyRed, VADM, whatever backend you have available, right? And that's it. Your model will be accelerated. Existing TensorFlow code, you didn't have to do anything. You just added two lines of code, and uh, uh, and you start getting benefit of OpenVINO toolkit optimization. So you didn't have to come out of your TensorFlow ecosystem. To what it is, so this is a product that enables OpenVINO acceleration with TensorFlow API. To TensorFlow, if you're using TensorFlow application, it has its own runtime where your model runs. Along with that runtime, we have brought OpenVINO runtime into the TensorFlow ecosystem. So as a developer, you don't have to do anything. Everything happens in line. We take care of all the things. You just need to take care of two lines of code. What happens, like inside inline, there are a lot of inline conversion that happens. Uh, uh, then uh, we There is a dynamic fallback. You get immediate acceleration. It's very friendly to transfer and incremental learning, and that's all. And it supports wider model coverage because it makes use of stock TensorFlow runtime and OpenVINO runtime. I'll talk about this later in the next slide. But any question here till now? Okay, so I'll go ahead and talk about yeah, why OpenVINO integration with TensorFlow. So this is for TensorFlow developers who are using TensorFlow API, and through this integration product, you can simply try out the OpenVINO toolkit, and it provide acceleration to all TF models as well. It just very easy to get onboarded. If you are working in a startup and you have resource crunch, you will not teach them OpenVINO because OpenVINO is a big API, right? Which has a lot of benefits. Maybe you will get more acceleration if you migrate to native OpenVINO toolkit. But if you want to utilize OpenVINO toolkit optimization by being in the TensorFlow ecosystem, because maybe you have a tight schedule, or you have less resources to maintain it going forward, then go ahead with OpenVINO integration with TensorFlow. So, well, there are two things. I talked about the OpenVINO native toolkit that will give you amazing performance, because there are some additional optimization steps that are available once you migrate fully to OpenVINO toolkit. But if you want to utilize a lot of good features of OpenVINO toolkit by being in the TensorFlow ecosystem, then you use OpenVINO integration with TensorFlow. So there are two products we are talking about. One is native product, that is separate API, and second is module, a Python module which you can import in your TensorFlow code. And along with the TensorFlow import statement, there is one additional line. Overall, there are two lines of code that if you add to your TensorFlow application, you will be able to utilize a lot of OpenVINO toolkit optimizations, and your model will be accelerated on TensorFlow on Intel hardware. So these are the things. So it's very simple: pick, enable, and run. Right? Pick a TensorFlow model, enable the OpenVINO backend with by those two lines of code, and just run it using TensorFlow API. No need to come out of that. Yeah, so we have currently like 450 plus models supported, and performance of each model is getting converted. It is getting improved. We have lot of models where we are very good at, and with each release we are improving the performance on some models. Our upcoming release will be a very good improvement on SSD and MobileNet, SSD and faster RCN and object detection model. We are very good at YOLO. uh, in classification model we are very good. You just add two lines of code, you'll see the performance acceleration. And also, like, if there's long term engagement kind of thing through your firm or the company you're working with, right? If you want to integrate in one of your solution, you can onboard as independent software vendor, and will be happy to talk to you. And then enabling OpenVINO backend in the TensorFlow application, in that code base is just adding two lines of code, and then run it. And here, if you see, like, we have already, if you're using TensorFlow, then you have TensorFlow inference engine already in place. And through those two lines of code, we have brought OpenVINO inference engine. So when initially when model graph comes, so we go through, traverse through the graph, and then we check. There are many operators in the TensorFlow graph. We check which operator is supported by OpenVINO backend, so that we can accelerate those operators, and which operators are not. Basis this information, we do subgraph partitioning. So out of the model TensorFlow directed a cyclic graph, we create many subgraphs, and then we decide, okay, if all that subgraph is supported by OpenVINO inference engine, then accelerate it through that. And if it is not, then use the TensorFlow inference engine as it is, as it was before. Even if 80% of the model is supported, the 80% of the model will be accelerated by OpenVINO inference engine through this OpenVINO integration with TensorFlow. So all these things, guys, I'm telling because these things are happening under the hood. As a developer, you don't have to worry about anything. Just add two lines of code. That's it. Yeah, the platform we support CPUs, Intel CPUs, integrated GPUs, Movidius, Vision processing units, VPUs, MyRadix, SDDL. We have support for Docker. We are our pre-built images. You can find it on Docker Hub. Uh, Also, one more thing I want to highlight. Uh, you guys must be knowing about TensorFlow serving. It's a big community, right? You have a TensorFlow model, and just to serve that model, okay, you take that model and serve it on a model server, correct? Uh, then through your client application, you pass on the data through HTTP request or something. Then your model server will get that data and send you the prediction by response. right? By sending you a response. The TensorFlow model server is a big community. So maybe once I come to your platform next time, to will have TensorFlow serving. But I want to tell you about TensorFlow serving. It's a very go-to solution for TensorFlow developers. If you have built a solution model on TensorFlow, just serve it using TensorFlow serving. And there, if and there also, what happens? The serving happens in the model server. There also we have integrated OpenVINO integration with TensorFlow. So in the Docker Hub, you will find OpenVINO integration with TensorFlow's pre-built image with TF serving support. So this the pre-built images, and also it is available on our GitHub. There you can build OpenVINO integration with TensorFlow image along with TensorFlow model server. So in your solution, if you're using TensorFlow model server, just replace it with uh, OVTF version of TensorFlow serving Docker image, and that's it. You will be able to get acceleration. And OS currently we support Ubuntu 18, 20, Windows 10. There is a preview. There is a initial support for Mac OS as well. And these are the resources that I have anyhow shared with you. But yeah, so now, guys, let's go to the demo part. Let me unshare and let me share my screen, full screen. So any question till now?
Yeah, I was just getting to the point, like when do we go for TensorRT and few inference engines like that, and then when do we go for OpenVINO? Because I was able to see from your thing, like we can also kind of improve the inference even on CPUs and multiple architectures. Like, so can you just tell me what's going to happen if I'm going to use OpenVINO instead of using a standard TensorFlow? Can you tell me what's going to happen a little bit more on the background so that it gives me a little bit
Yeah.
more like
I'll just talk about it more. Suppose you are using TensorFlow as it is. You are happy with that. Okay, your life is okay. Maybe suppose in some use cases your inferencing speed will not be adequate, right? In that case, if you are using Intel hardware CPU, or maybe if you want to use Intel GPU or VPUs, you want the model to be accelerated. Or even if I'm using TensorFlow, I've not added those two lines of code, right? As it is, your inferencing speed will be you must be getting some inferencing speed, right? If you want to accelerate that, just that is our solution is all about. Suppose to predict uh, one image, if your existing solution takes 1 second, so maybe with our solution, it will take half a second, okay, or half a second to predict one image. So that is the high level example. So we have lot of optimizations which is done after training the model. And talking about TensorRT is mainly for NVIDIA devices. It is for CPU. For Intel CPU, you can use open. You will have to use OpenVINO if you want to accelerate. But our solution doesn't work on NVIDIA, and their solution doesn't work on Intel. So that's it. So if you are using Intel hardware, then OpenVINO is the only solution. Yeah.
okay. So does OpenVINO work on AMD and things
No.
like that, or is it only for Intel?
Intel, super optimized for Intel, because we know the hardware, right?
Alright.
We know the hardware architecture, the electronics engineering part, like how we have designed to then it interfaces with the solution, and finally we know what to run and where to run, right? And where to run is very personal to us. So there we have done some optimizations.
All right. So just wanted to add a little bit more point here. So say for example, I'm using OpenVINO, and then probably before using OpenVINO, I am trying to perform some optimization like bit quantization and all those things. And then if I move to OpenVINO, is there going to be some considerable amount of accuracy, or is it going to be pretty standard, right? So say for example, I am using TensorRT, let's just assume for now I'm using TensorRT, and then I just put TensorRT on top of that, I am using OpenVINO or some framework like that. Does that bring in any change or not?
No, but that will not be wise anyhow, because you are adding load to your system, right? And the steps which are common, right? Quantization and other things, those will be repeated, correct? Like you're using two modules to get the same thing, and maybe their quantization, like if I talk about standard quantization, that is okay, like but if any hardware specific they are doing, and it might clash, right? So if you have to maybe just try to see the possibility where you have trained your model before doing any optimization step, right? Just try to run it with OpenVINO native toolkit or the integration I talked about, right? And then you can, because it's the same stuff, right? I'm using I've imported two libraries in my code base, and calling the functions, means maybe a sort function is present in all, right, in both the libraries. So I will use anyhow one, right? uh, so that is the scene here. What is your end goal, right? That is how we need to architect the solution. Like, what is your end goal where you want to try, right? Uh, Maybe at the benchmarking phase, you can definitely say that, but how your final solution looks like, the architect will give thought on that. And then after that, accordingly, you will select the proper libraries.
All right, just one last question. So
Yeah.
does OpenVINO work on TensorFlow Lite and all those things as well?
Yeah, TensorFlow Lite, OpenVINO integration with TensorFlow that I just talked about, right? That will have TensorFlow Lite support in upcoming releases. Okay, not now, but OpenVINO, the native OpenVINO, works on Lite model as well. I need to
Okay, all right.
confirm it, but as per my knowledge, it supports TensorFlow. So there are two products I talked about, right? One is like native toolkit, and that is the another that we have integrated with TensorFlow. The portion that we have integrated with TensorFlow, that doesn't have TF Lite support as of now, but it will have in upcoming releases. That is part of our roadmap. But in native OpenVINO toolkit, you can definitely check their documentation. It will be straightforward present there.
Okay, yeah.
Yeah. Any other question, guys?
So Kumar, do we have any comparison like between the inference time with OpenVINO and without OpenVINO?
Like with OpenVINO, it is there in the documentation. But for OpenVINO integration with TensorFlow, right, we haven't released it yet because we want you guys to test it because it's a low code solution, right? But the benchmark is like what OpenVINO provides to will be around that number. Okay.
Okay.
Because we make use of OpenVINO toolkit optimizations, right? We spot the operators in the TensorFlow graph, and then we see that whether we can accelerate it or not. So how we are accelerating those operators through OpenVINO, right? The OpenVINO documentation has everything like all benchmarking, and we try to be near that. There are some additional steps and more hardware control available there. But in OpenVINO integration with TensorFlow also, we can work on some model and provide some focus report support also.
Okay. Do we have benchmark for resource utilization as well?
Yeah, that is there in for the OpenVINO. For again, I told about this OpenVINO integration with TensorFlow, right? It's a low-code solution and it's very specific to the use case people are using. So we want them to test that mem. But having said that, even it goes with NVIDIA's solution or Intel solution or in your memory footprint will be little bit large because we are bringing one additional runtime, right?
Mm.
But it won't be that much. It is optimized in a way. Yeah,
Okay.
but OpenVINO has all the data, and here it's very simple, right? You just you have a benchmarking script and memory utilization for your TensorFlow application. That you just need to extend it once you add 2 lines of code. That is why we don't explicitly provide in the documentation, because if you're doing that benchmarking for your TensorFlow application without adding any accelerator as such, using as vanilla TensorFlow, then you must be having those scripts. You just add 2 lines of code and rerun that. So then you will get the exact picture, right?
Yeah, sure, we'll explore. Thank you.
Yeah. So I'll just share my screen. Uh, I'm sharing my whole window. Okay. Hope you can see the. Yeah, I
Yes.
think it can be seen. Now I had other stuffs here. Okay. What happens under the hood? Okay. Under the hood, what OpenVINO integration with TensorFlow does with those 2 lines of code? We have OCM, Operator Capability Manager, that identifies which. So this is a standard TensorFlow graph. It has many operators, right? Convolution, reshape, and select, and all those. So in that, suppose the highlighted red one is not supported by OpenVINO currently. TensorFlow supports that, okay? But OpenVINO doesn't support it. Doesn't support what I mean by that. Can it accelerate it further? Yeah. So that kind of thing. So it spots, the first module spots whether a particular operator is supported for acceleration in OpenVINO or not. Then accordingly, we do the subgraph partitioning. So we create multiple cluster like cluster 0 and cluster 1. Those can be accelerated because those are OpenVINO compatible clusters. Then what happens, like we have clusters TensorFlow subgraph, and then accordingly we create intermediate representation of this subgraph. So out of main TensorFlow graph, we have created many subgraph, right? And basis, what was the basis of that subgraph? Cluster 0 and cluster 1, right? 2 subgraphs we created out of the whole TensorFlow graph, and those are converted into intermediate representations. And those intermediate representation graph will run on OpenVINO inference engine, and you will get the acceleration. So we have many backend support like CPU, IGPU, MyRad. So it is very tied to these, and on Intel hardware on these CPU, IGPU, MyRad, right? You will get very good performance. Internally, the sub model or sub graph, right, that gets converted into IR, and that runs on these backend. So well, that's what I wanted to just show. Like there are a lot of things happening behind those 2 lines of code. Okay, and just to get the hang of that, I'll just take you to the home page. Okay, can you see the Chrome browser?
Yes. GitHub.
Yeah, yeah, perfect. So well, if you search for OpenVINO and TensorFlow, most probably you will get this GitHub page. If you're getting any GitHub link, that would be this OpenVINO integration with TensorFlow. To what we have done, we have created a product for TensorFlow developers who want to get started with OpenVINO. OpenVINO is big, another API, right? In their inferencing application. So this is, you can read about the product. It just requires you to add just these 2 lines of code to your application. That's all. And here, if you find, you will see like examples. Let me have a check on the time. Yeah, examples, and there you have notebooks. Examples notebooks. Uh, Guys who want to try this, they can try with me live also. So just guys, I'll just paste here. Okay. Mm, where to put in the chat?
It's on the left side. Sorry, right
Yeah,
side.
got it. Right hand side. So guys, can you go to this? Guys, just spam the chat with yes. Perfect. Perfect. I'll give 30-second more. Okay. Perfect. Well, now once you're here, then you can see there are 2 notebooks, classification and object detection. So let's click on the classification, because in object detection, there is a step of model conversion that takes time. So just for the interest of time, just click here and you'll find a button open in Colab. And once you click on this, then the notebook will open in Colab. You should be logged into your Google account. So it will open in the Colab. Now I can run it. So it talks about image class. The first cell is more on setting up some environment variables. This TF enable 1DN optimization. This environment variable will be by default enabled from TensorFlow 2.9. So you don't have to worry about enabling this. Here, it will be by default enabled if you're using TensorFlow 2.9 or above. It optimizes, brings 1DNN optimizations on Intel hardware. And on top of that, we work. And then this is another environment variable that we recommend to enable. It squeezes more power from OpenVINO integration with TensorFlow. It just converts a variable into constant. It freezes the graph. So just run it. You'll see that button run anyway. Let it run. But yeah, got it. So then the script here is very simple. Like it checks like if you have already installed a particular version of TensorFlow, what is required, and then it doesn't install. If it is not installed, it installs. Now, once all those installation is done, yeah, almost like all installation, everything, it's a standard thing. Now there is inferencing. It's a standard import statement, and I was talking about the 2 lines of code. One of the line is this one: import OpenVINO as OVTF. And other section of this notebook, right? Any TensorFlow developer who has worked on classification, image classification, would be knowing. We have just for this notebook, we have taken an image classification sample and tried adding those 2 lines of code after those installation steps, and tried to gauge how much gain we are going to get. So import is done. This pre-processing image, it reads input image, resized to given input height and width, and returns the pre-processed image. So it's a pre-processing function. It's very a typical TensorFlow developer would be familiar to this function. Loading Cocoa labels. This is also very standard stuff. And this is an inferencing function. additional thing, we have added an iteration of warm up. So when your model is used to predict im- uh, the class of image for the first time, the first inferencing, that we call it warm up, because there are many one-time optimization steps that happens. So we recommend, right, if you are using OpenVINO integration with TensorFlow, just run 5 iteration for warm up, and then after that you measure the inferencing time, right? That will be, then that will represent a real picture, like how much gain you are going to get before you deploy it in any real-time application. Let's run it for the first 5 iterations. For most of the models, 1 iteration is fine, 1 to 3 iteration. Here I have just taken 1 iteration, okay? And from the second iteration onwards, I'll just measure the inferencing speed. And here I'm just passing the image and all those things. And I'm just setting the backend here, the second line of code. These functions are just to test which backends are available. And once, if you are sure about which backend you have, CPU or GPU, you can directly call this function. This is the second line. And let's see like how we, what is the time we get. Yeah, run it. And this function, I'll talk about all those. And having said that, guys, you might see some different number because it is shared resource and free resource, right? So that is why you might see some different number. Like here you can easily see that here we have added those 2 lines of code, and OpenVINO integration with TensorFlow is enabled. And inferencing, we run it for some iterations, and for each iteration you can see that 194, 186. So this is the average inferencing time it takes to infer from one image. Okay. And similarly, if there's an API to disable OpenVINO integration with TensorFlow, suppose you don't want to use OpenVINO integration with TensorFlow and you want to use, you want your code to behave as before, before OpenVINO integration was enabled, just call this ovtf.disable. We called this and we saw that, okay, generally it takes like almost 269 to 71 seconds to inference, to infer one image. You can really see the difference, right? Let's run it again. In real time, you can play and just disable, then it becomes like the old TensorFlow. It will only use a native TensorFlow runtime. And you can see that. You can see the difference, right? 182 milliseconds. And what we did, actually, we just added this backend, 1 line of code, and we after installation we imported, definitely to use the function we need to import, right? So that's what we did to a TensorFlow classification example, and boom, we got this much performance gain. That's all I wanted to show. Yeah, any question, guys? Let me check the chat. Perfect. Also, guys, if you know about TensorFlow serving, I just want you to point it out to go to homepage, and here you have Docker. Once you go to Docker, right, or inside docs also we have given the hyperlink of this. So it has details of all the Docker images available on Docker Hub, or you can build it, right, the instructions to build. And there comes TensorFlow serving. It's a standard way you have trained your model and you want to serve it using TF serving. Then this is what you do these steps. You build the TensorFlow model server, TF serving Docker image, and you follow these 3 steps. You have your model, then you start serving that model by giving the path to the model, and the part to the Docker image. Now, if you replace that TensorFlow serving workflow with TensorFlow serving with OpenVINO integration with TensorFlow, where we have combined both. We have like in the Docker image itself, we have added the TensorFlow model server is there. So with that also we have integrated OpenVINO integration with TensorFlow. So then you just replace it with the OpenVINO integration with TensorFlow Docker image, and that's all. Your workflow of TensorFlow serving will work as it is. Plus, you will get some optimization and quicker inferencing speed. Yeah. So this document is here, like it tells you like a classic. I'll also share this thing. This instruction you will get it on uh, TensorFlow serving official page. So this Google provides this client script where you have model and you just point to an URL where your model server is there. If you point to that the model server which has OVTF OpenVINO integration with TensorFlow, this client script will work with that also. So it's that simple. Yeah, guys. So that's all I had. Please, we are exactly on time. Any question, please feel free to us. I would love to talk to TensorFlow. You guys, tensors.